Hello, welcome to the Maths Matrix and part 5 in the percentage series. My name's Rebecca and in this lesson we're going to be doing reverse percentage. Reverse percentage is the aspect of percentage work that people most commonly struggle with and get confused about, and so for that reason it's almost always on exams every year, regardless of which board you're studying with. I'm not going to put a list of questions on screen for you to have a go at, because not only can people commonly not do reverse percentage, but they often don't even realise that they can't do it, so they think that they're getting them right when actually they're not. So we're just going to get straight on with the lesson. You'll be needing paper, pen and a calculator. Assuming that you've got those, continue on with your notes from the previous videos and put a subtitle of Type 7 Reverse percentage. And then put reverse percentage questions involve looking back in time to work out what something was before a percentage increase or decrease was applied. Phrases like originally, at the start, before, last year, etc. might indicate that you are dealing with a reverse percentage scenario. And then we'll do an example question. So if you just put e.g., Emily is saving up for her summer holiday. She decides to reduce her weekly food bill by 15%. She now spends £51 a week on food. What did she spend each week before she started saving? Okay. And then put method 1, non-calc. Now you could spot in an exam that this was a reverse percentage scenario because you're being told something is this now. What was it before? So if you're being asked to look back to what something was before, then you've got yourself a reverse percentage scenario, okay? Now we're told that Emily decreases her food bill by 15%. So if she decreases her food bill by 15%, then that means that there's only 85% of it left. And that 85% we're told is worth £51. So our first line of working would say 85% equals £51, okay? Because it's been reduced by 15%, and we know that after it's been reduced by 15%, i.e. it's 85%, that it's worth £51, because that's all in the question. I tell students to ask themselves the question, what percent do I have here? And that's always your first line of working in reverse percentage questions. So if you want to, off to one side, just put, ask yourself the question, what percent do I have here? Then scale this down and back up to find 100%. So that there is our first line of working. 85 must divide by 5 because it ends in a 5 or a 0. So I could divide 85 by something to give 5%, and that something is 17. So if I divide 85% by 17, I get 5%. And so I can divide 51 by 17 as well. This is a lot like ratio work, where what you do to one side you have to do to the other side to keep it balanced. It's a very similar thing, really. So 51 divided by 17 is £3. So that tells me that 5% equals £3. And why was I trying to find 5%? Because 5 scales up nicely to give me 100%, because 5 is a number that will fit into 100 a whole number of times. So now that 5% can be multiplied by 20 to give 100%, and the 3 can be multiplied by 20 as well to give £60. And that's what she would have been spending before the percentage decrease was applied. Okay? So on a non-calculator paper, what we're looking for is something that we can divide this by that will give a number that can then be scaled up to fit into 100. So 5%, 10%, 20%, 25%, they're all numbers that would fit nicely into 100 a whole number of times, whereas 11% won't go into 100 a whole number of times because 100 isn't in the 11 times table. 14% won't be useful either because 100's not in the 14 times table. But anything that will fit into 100 a whole number of times, i.e. anything that eventually has 100 in its times table, is a useful chunk that you can scale down to. It's just a question really there of knowing your times tables, so of being able to spot that that must divide by 5 because it ends in a 5, of spotting that it can't divide by 2 because it's not even. So that gets back to your divisibility rules and your ability to multiply and divide quite confidently. There's no trick beyond that really, just knowing your times tables quite well. But you're looking for something that fits into 100 to scale down to, and then you scale that up, and what you do to one side you have to do to the other as well. All right, so that's how you do it without a calculator. If you now put method 2 calculator, now on a calculator the method is similar but the numbers are just not as pleasant. So we'd still start with 85% equals £51. That's going to be our starter point for both methods. If we didn't know that we could divide by 17 to give 5 and by 17 to give 3, or if we were just working on a calculator paper, just scale all the way down to 1%. So if we divide whatever's on the left by itself, so in this case dividing 85 by 85, that will give us 1, because dividing something by itself always gives us 1. So we'll divide by 85 on the left to give us 1. And so because I've divided by 85% on the left, I also need to divide by 85% on the right to keep it balanced. So at that point on a calculator paper, you would just put into your calculator 51 divided by 85. And if I pop it in, it comes out first of all on my calculator as a fraction. So that's when I have to press the S to D button there. And it changes it into a decimal for me, like that. So 1% equals 0.6. So if I times that 1% by 100, that'll give me 100%. So because I'm timesing 1 by 100 to give me 100%, I have to times 0.6 by 100 as well. So I would just then put times 100, the answer into the calculator, like that, to give me an overall answer of 60, same as before. So I would still get the same answer, obviously, but just using a calculator instead. All right, let's do another one. So if you put EG, in his real GCSE, George scores 10% more than he did in his mock. He gets 99 out of 120 in his GCSE. What did he get in his mock? So again, on an exam, you would know that this was a reverse percentage question because you're being told now he's getting something. What did he get beforehand? What did he get in the past? So it's a reverse percentage scenario. And you would start off by asking yourself, what percent do I have here? Well, in his real exam, he scores 10% more than he did in his mock. So he scores all that he did in his mock, 100% of it, plus another 10%. So we have here 110%, and we have here 99 marks. So 110% equals 99 marks. So if we were doing this without a calculator, we'd be looking for a chunk that we could scale down to, which would then fit into 100. So if I divide this by 11, that will leave me with 10%, because clearly 11 times 10 would take me back to 110. So if I divide it by 11, I get 10%. And again, that's just a case of knowing your tables and number work quite well. There's no other trick to that part. So because I've divided by 11 there to give me 10%, I have to divide by 11 here as well. And 99 divided by 11 is going to give me 9 marks. So 10% equals 9 marks. Then I can times by 10 to scale it up to 100%. So 10% times 10 would give me 100%. And 9 marks times 10 would give me 90 marks. So in his mock, he got 90 marks. And you can check if your answer makes sense, because we're told in the question, in the real thing, he gets 99, which is a 10% increase on what he got in his mocks. So in other words, he did better in his real exam than he did in his mocks, which means that you want a lower score for his mock than he got in his exam. So you can always look at your answer and think, has it gone the right way? Has it gone in the right direction? And if it hasn't, then you've done something wrong. But here, this does make sense because he did worse in his mock at 90 marks than he did in his real exam at 99 marks. Okay? So that's how we do it without a calculator. We'll now do the same question again with a calculator. So if you just put method 2 calculator, and you can label that method 1 non-calculator. So again, we would ask ourselves the question, what percent do I have here? Which would be the same starting point as before. So 110% equals 99 marks. But this time, if we had a calculator, we could just come all the way down to 1% there. by dividing by 110. So if we divide that by itself, we get 1%. And so we have to divide that by 110 as well to keep the sides balanced. So you would literally just put into your calculator 99 divided by 110. And again, on my calculator, it pops up a fraction like that. So I would just press the S to D button to give me a decimal, which would be 0.9. And then to get from 1% to 100%, we times by 100. And so because I'm timesing by 100 on the left, I can also times by 100 on the right. So leaving my answer on screen, I could then just hit times 100 equals, and that'll give me the same answer as before, 90. Okay? So 100% equals 90 marks. On a calculator, there are other ways of laying it out. So if you have a different way of writing it down and of doing it on your calculator, then feel free to use that. But if you don't, then I quite like this method. And the reason that I like this method is it's quite versatile. So this same method can be applied to ratio questions. It can be applied to exchange rates. So if you have $1 equals 85 pence, you can scale both sides down and then back up again to do an exchange rate currency question. It scales up quite nicely to those baking problems where it says this much butter makes that many cookies, and you ultimately have to find out how many cookies you could make with a different amount of butter. It just lends itself to quite a few different areas of maths. So if you don't have a way of doing reverse percentage on a calculator, then I would recommend setting it out like this, just because it's useful for lots of other stuff as well. All right, let's do another one. So if you put e.g., a shopping bill comes to £72, including VAT, at 20%. What is the value of the goods before VAT is added? Now, if you're not sure how VAT works, what it actually is, then go back and watch the second video in the percentage series, because I explain about VAT and how it works in that video. But they're very fond of VAT questions on exams, so it's definitely worth doing a reverse percentage in a VAT context. We'll do this one without a calculator. And we're told that the shopping bill is £72, including VAT at 20%. That means that we have the cost of the goods and an extra 20%. So when we ask ourselves the starter question, what percent do I have here? We have here 120%. So 120% equals £72. And that would be our starter point. Now, if I divide that by 6, that will give me 20%. So 120 divided by 6 is 20, so that would give me 20%. And then what I've done on the left, I need to do to the right as well. So I can divide £72 by 6 to give me £12. And then 20% fits nice and neatly into 100%. That's why I picked it. So 20 times by 5 gives 100%. So I need to times 12 by 5 as well, which gives me £60. Now, you don't have to choose 20 as your chunk. Sometimes there's lots of options for what you can choose as a chunk. So if instead, if I'd used 120% equals £72 and then decided to divide by 12 to give me 10% and divide by 12 to give me £6 instead, then I would still have got the same answer, because instead of then timesing 20% by 5 to give 100%, I would have been timesing 10% by 10 to give me 100%, which means the 6 would have got times by 10, which would have given the same £60 as before. So not everybody will scale down using the same number to the same chunk, but what matters is that everybody ends up with 100% equals. We'll do another one, and this time we'll do a calculator example with harder numbers. So put e.g. a population of giraffes decreases by 8% in a 12-month period. By December 2019, there are 340 giraffes. How many giraffes were there in December 2018? So again, we would know that this is reverse percentage because we're being told to look back 1 year and say what was something 1 year earlier. So looking back in time, always reverse percentage. So we're told that the population of giraffes decreases by 8%. Well, if a population decreases by 8%, that means that there's only 92% of it left. So the answer to the question, what percent do I have here, is 92% is what I have here, and what I have here now is 340 giraffes. Okay. Now I said we'd do this one using a calculator. The clue would be it would be on a calculator paper in your exam. So if I divide 92 by 92, that brings me all the way down to 1%. So on a calculator paper, just come down to 1%, 9 times out of 10. So I'll divide by 92 there as well, okay? So I would do 340 divided by 92. And again, that would give me a fraction first of all on this calculator. So I would press S to D, and then it gives me a decimal that isn't a nice neat one. It's a really long one. So what I'm going to do is I'm going to write down quite a few decimal places. So I'm going to put 3.69565, and then I'm just going to put ... to show that the decimal went on, but that I'm not writing all the decimal places down because there's loads of them. But always work with more decimals in your working than you're going to need in your final answer. That's why I've chosen quite a few decimal places there. So we have 1% equals that. So if I times 1% by 100, that'll give me 100%. And because I'm timesing by 100 there, I need to times by 100 there as well, which I could do on the calculator if I didn't know to just move the decimal place. And that would give me 369.56 ... Okay. Now, because this relates to giraffes, which are discrete data, so you either have 1 giraffe or 2 giraffes or 3 giraffes, you don't have 1.5 giraffes or 2.25 giraffes, I'm going to round this down, because if I don't have enough, even though normally you would round that up to 370 because it's a 0.5 there, because I don't have enough for 370 complete giraffes, that means I only have enough for 369 giraffes. So in the context of this question, I will round down because I don't have enough for 370 full giraffes. All right? So on a calculator, down to 1% and then back up to 100%. All right? We'll do one more. So if you put e.g. a business decides to increase its advertising budget by 18% in the next financial year. It plans to spend £3,600 next year. What did it spend on advertising this financial year to the nearest pound? So in this case, we're being told that the new advertising budget after an 18% increase is £3,600, and we're being asked what was it before, what was the old advertising budget. So because it's gone up by 18%, we have all of the previous advertising budget plus another 18%. So the answer to what percent do I have here is 118% equals £3,600. Okay. So bringing this down to 1%, we would divide by 118. So we would need to divide by 118 on that side as well. And that would just go into the calculator. So 3,600 divided by 118 is 30.50847 ... And if that's 1%, then I can multiply by 100 to give me 100%. So I need to multiply by 100 there as well, which would give me 3050.847 ... And the answer said to the nearest pound. So to the nearest pound, that's 305. And then because that's bigger than 5, that comes up to 1. So 3,051 is what the old advertising budget was. All right. And that's reverse percentage. So if you're on a non-calculator paper, then you're looking for a chunk that will fit back into 100, and you scale down to the chunk and then up to 100. And if you're on a calculator paper, then you just scale down to 1% and then back up to 100%. But you're almost always looking back in time to what something was beforehand, and that's how you'll know that you've got one of those questions. All right? So I'm going to put some questions on screen now. Some of them are to be done without a calculator, so you can practice the chunk method, and some of them are to be done with a calculator, so you can practice this method that I've just used here. And I'll put the solutions on afterwards so that you can mark them and check you've got them right. Okay? Thank you very much for watching. I hope you found that useful. If you did, please consider subscribing to the channel or leaving me a thumbs up, and I'll see you in the next video where we'll be doing some exam style mixed percentage questions so that you can practice figuring out for yourself whether you've got a type 1 or a type 3 or one of these reverse percentage questions, because they don't tell you in exams what type of percentage question it is that you're actually dealing with. So that's what we'll be doing next time. Thank you.